Hi. One of the big problems we find in write-ups in particular, people draw graphs of their data and they don't really fully understand or explain what the graph means. So let's have a quick look at some of these and let's look at the common ways or the common things a graph shows us. Alright, all of our graphs should have the dependent variable on the vertical axis, on the y-axis, and the independent variable on the x-axis. Now I've just put them as dv and iv, right? And of course we would have units and the full labels with it. So make sure you have those and make sure you set your graph up so it is that way. It's a good start. Alright, a typical graph is this one. We've got a linear progression, alright? We've got a constant rise, so that should be something that should be set in there as well. I'm leaving that out because I've already done a section of videos on straight line graphs. Right, so this tells us we've got a constant rise and we have a relationship between these two variables. And the relationship is a linear. So we can't say it's a proportionality at this stage, but we can say there is a linear relationship that if the IV goes up, independent variable goes up, then the dependent variable also goes up. So there is a proportionality relationship, and if you go further, you can look at things like the slope of the graph to help you go through this. But this is one thing you should be telling me in your write-up as you go through. Alright, here's a slightly different one. Notice this one doesn't go through the origin. Not all graphs go through the origin. And this basically down here tells me what the dependent variable value would be at the zero independent variable. In other words, if we didn't change anything. Alright, so it's pretty much the same. So again, we see there's a good relationship. The slope, as it says here, will tell us about the relationship, and as you go further up into 10, 11, 12 and 13, you should be spending a little bit more of your write-up telling me about the slope and what that actually means. So, but obviously, the greater if it went up like that, the greater the slope, right? Obviously, the faster the change. Right, and as you can see, there is a bit of an explanation of what's going on. These sort of things should be appearing in your write-up. I'm going to harp on that because it is part of the assessment criteria. Right, here's the reverse happening, but in some ways it's very similar. Right, this time we've got the graph going down, if you like. It's got a negative slope on it, and so we see again we've got a constant change. And we've got a constant change in the negative direction. So in other words, as the independent variable rises, the dependent variable falls. So they are opposite to each other, if you like. And it says here inverse relationship. Don't use terms unless you're happy using them though. Right? Don't just write down this is an inverse relationship. You should then expand on that to tell me that as one goes up, the other goes down. Right. So we can see there's some basic ones so far. Let's look at this one. We've got a flat line. So in other words, the dependent variable does not change as I change the independent. We can see that the variables, we can't say there is a relationship between them. This doesn't happen very often. Most of the time they'll get a slight slope on them. All right, well, so moving on, this is quite common in some things. We have a slow rise, then quickening. So how do we go about that one? Well, we don't have a constant change anymore, do we? As I said, it starts off slowly down this end. So as the independent variable starts to change, the dependent variable slowly changes. And as the independent variable increases, the dependent variable changes faster. Now, as it says here, it's sometimes called an exponential change. Alright, lucky last. We have this one where it goes up and then flattens out. Now this is quite often a biological one, so you might find this a few times in biology. And no, you haven't done the experiment wrong. It simply means that you've got it right. Because a lot of times we actually reach a limit, if you like, and then it stops rising. So we should say, all right, there is a relationship between these two things, the dependent variable and the independent variable. It starts off at a low change in independent variable. It changes its dependent variable quickly, and then it gradually slows down. So our slope or gradient changes all the way up, and then finally it almost flattens out. So it reaches maximum value and then plateaus off. And as I said, this is quite often the case in a biological experiment. Right, there's some changes. There's some things you should think about writing. Have a look at this. Use this in your analysis of your graph, if you like. All right.